Hello children, welcome to Minutes of Maths. In this class, I am going to teach you Class 9, Chapter 7, Triangles, Exercise 7.2, Question number 1. In an isosceles triangle ABC, with AB is equivalent to AC, the bisectors of angle AB and angle C intersect each other at O. Join A to O and then show that OB is equivalent to OC. And second one, AO bisects angle A. This is the figure given in the question. In the question, they have given ABC is the isosceles triangle and the two equal sides are AB and AC. These are two equal sides. So, this is the isosceles triangle. We know in isosceles triangle, opposite angles opposite to the equal sides are equals. That means this angle is equivalent to this angle because these two are equal sides and angles opposite to the equal sides would be equal. So that angle B is equivalent to angle C. And then the bisectors of these are the two bisectors OB and OC. Both are bisecting the angle B and angle C. So, if OB is a bisector, then we can say this angle ABO is equivalent to OBC. These two are equal to each other and these two are equal to each other because this OB is bisector of angle B and OC is bisector of angle C, that is given in the question. Now we have to join O to A and then show that OB equal to OC and then this line OA is bisecting the angle A. These two we have to prove. You can see first one is OB is equivalent to OC we have to prove. That means what they are telling, we have to prove OBC also isosceles triangle. When we can say this is isosceles triangle, if these two angles are equal, then we can say these two sides are equal to each other. So already that is proved by this bisector OB. Bisector OB is bisecting the angle B and OC is bisecting the angle OC. Already these two, angle B is equivalent to angle C and angle OBA is equivalent to angle OBC because OB is the bisector of angle B. And one more thing, angle ACO is equivalent to angle OCB because OC is the bisector of C. So, if these two angles are equal to each other, then we can say the sides opposite to the equal angles would be equal to each other according to the isosceles triangle. So, we are going to prove like this. Let's write the statement. Solution. Now we have to consider first triangle ABC. In triangle ABC, AB is equivalent to AC, that is given in the question because this is the isosceles triangle. And angle ABC is equivalent to ACB. We can prove by the property of isosceles triangle. Angles opposite to the equal sides would be equal to each other. So, this angle would be equal to this angle. Next is half half of ABC is equivalent to half of ACB because OB is the bisector of ABC and OC is the bisector of ACB. So that I can write half of ABC is equivalent to half of ACB. You can see here half of ABC we can write OBC2 because angle B is divided into two equal parts ABO and OBC. So we can say this OB is the half of ABC. So that I am writing instead of half of ABC, I am writing OBC. And instead of half of ACB, I am writing OCB. So these two angles are equal to each other. Now we have proved. You can see when these two angles can be equal to each other, if these two sides are equal to each other, then this angle also would be equal to each other in isosceles triangle. So we can write sides opposite to equal angles of a triangle are equal to each other. So by using this property, I have written here OB is equivalent to OC. First part is over. Now we have to prove, we have to join this A and O, and we have to prove this OA is the bisector of angle A. This angle and this angle would be equal to each other. So for that what we have to do? We have to take these two triangles AOB and AOC to prove this. Let's prove in the next page. I have joined this A and O. Now we are going to take this triangle AOB and AOC. So that I have written here triangle ABO and ACO. You can see this OA is the common for these two triangles. So this is common. This we have already proved in the first part. OB is equivalent to OC, and this is already given in the question. AB is equivalent to AC. So we can prove this is the common. So we can prove according to triple S rule, these two triangles are equal to each other. One more rules also we can use here, that is you can take these two sides and this angle also you can use, because in the question this is the isosceles triangle and this angle and this angles are equal to each other, and these two angles are half of ABC. So that here I have used this rule side angle side to prove these two triangles are congruent triangles. So that I have written the steps like this. AB is equivalent to AC, that is given in the question, and angle OBA is equivalent to OCA is half of ABC and half of ACB. So that I can equate these two angles, this angle and this angle. And next is OB is equivalent to OC, that we have proved in the first part. So that by SAS congruency rule, I can say triangle ABO is equivalent to triangle ACO. If these two are congruent, then we can say these two angles are corresponding parts of congruence triangle. We know corresponding parts of congruence triangle would be equal to each other. So I can say this angle OAB is equivalent to OAC by CPCT. If these two are equal to each other, that means what? This OA is bisecting the angle A. So that I have proved AO bisects angle A. That's it. Let's move on to next question. Question number 2. In triangle ABC, AD is the perpendicular bisector of BC. Show that triangle ABC is an isosceles triangle in which AB is equivalent to AC. This is the figure given in the question. ABC, this is one triangle ABC. In that AD is the perpendicular bisector of BC. So this is the perpendicular line for BC. So these two AD and BC will together make a right angle, we know. If one line is perpendicular to another line, then both the line will form a right angle. Right. AD is bisector of BC, that is given in the question. So if this is the bisector, then we can say BD is equivalent to DC because AD is bisecting the line BC. We have to prove this ABC is a isosceles triangle in which AB is equivalent to AC. We have to prove these two sides are equal to each other. For that, what we are going to do? We are going to take this triangle ABD and ACD. We have to take these two triangles. You can see in these two triangles, AD is common for both the triangle, and one angle is this angle is 90 degree in each triangle, and this side also equal to each other because AD is the bisector. Now you can see one side is equal and one side is common. Two angles are equal. So we can use the rule side angle side to prove ADC and ADB and ADC congruence triangle. Let's write the statement. In triangle ABD and triangle ACD, already I have told AD is common. This is common. And angle ADB is equivalent to ADC. This both are 90 degree each. And BD is equivalent to CD because AD is the bisector of BC. So this is equal to each other. So according to SAS congruency, I can write this triangle ABD is equivalent to triangle ACD. You can see now this AB and AC, these two are corresponding parts of congruency triangle. So we know corresponding parts of congruency triangle would be equal to each other. So by CPCT, I can say this AB is equivalent to AC. That's it. If these two are equal to each other, then we can say this ABC is a one isosceles triangle. Hence, we have proved. Thank you.